The tools typically used are called fluting tools or sometimes a ball end mill, and they may be purchased as a set of 4, or you may choose to only run one and then hand finish the flute after it's cut. These tools will need to be added to your AlphaCam tool library. You can draw them and add them in as a user-defined tool, but really, the only part of the tool that will be used in fluting the drainboard is the bottom round tip. We won't ever cut or profile with this part of the tool, so I can use the shape of the tool to the right, and I can easily get that without even drawing it. If I go to my Machine tab and choose Define Tool, I'll be able to select Ball End from the choices provided, and I'll fill in all the information about the tool: its tool number, offset number, its length, its diameter. I'll turn on Flood, and then I'll input the feeds and speeds that should be provided by the tool manufacturer. When finished, click OK, and then we can save this tool as a name. Repeat this process for each tool that you want to enter into your tool library. When you're finished, you can choose Select Tool, and then you can view the properties and make sure that they're entered correctly. Now with the tools set up in AlphaCam, we'll draw in some lines for our drain board. For this example, I'll just offset the edge of the sink, the distance that I would like to be the length of my flutes. I'll just use 9 inches, and I'll offset it as a construction line. I'll select this line to this side. And now I can draw a line from the middle of this edge of the sink to the middle of this construction line, which I can delete now. I'm going to extend this line past the edge of the sink because I want the tool to lower into the sink cutout instead of plunging into the material. I'll do this with the Extend by Distance command, which is on my Edit tab. I'll use a value of a 1/2 inch. My tool is a 1/2 inch diameter, so that'll give me a little extra clearance. The white X that shows me the start point of the line also shows me the start point of the cut. Later, we'll edit a slope in, so it starts low at the beginning of the cut and raises. This helps cut with the side of the tool rather than putting a lot of pressure on the very tip. If needed, you can change the direction by going to the Machine tab and choosing Tool Direction. Verify or select these 3 settings: Reverse, No Change, and No. Then you can select the line, which will change the direction, verified by an arrow. This line is now properly prepared for cutting, so I'm going to copy it or offset it, whatever distance and how many times I need. I'll use a distance of 2, select Line Arc, and Offset as Geometry. So I can offset a few this way, and I'll also offset a few this way. And at this time, if you're programming a Titan, insert the table template and locate your piece on the table and set your vacuum pods. If you're programming a Voyager, place your part to reference with the stops on your table. Next, I'm going to add a material thickness so I can see my parts cut in simulation. I'll go to the 3D tab and choose Set Materials. Then as prompted, I'll choose the outside shape of my countertop. And for this example, I'll be programming 3cm material, so I'll enter in 1.181 for the material top. I'll leave the bottom at 0. And since we're not programming the outside of the countertop, it doesn't matter if I check Delete Original Geometry or not. So I'll just leave it the way it was. Click OK and finish setting the thickness of my material. And we're ready to start applying toolpaths to create our program. We'll start by first selecting a tool to use by going to the Machine tab and choosing Select Tool. I'll start with position 1 by double-clicking on it and then clicking once in the drawing to insert it as the active tool. And now I can go to Cut Shape to input all my cut information. Under Types, I'll leave Vertical and Selection checked. Under General, we'll set compensation to the center of the tool rather than using Machine Comp. And we can also verify that we have the correct tool selected. The values that we enter under Levels and Cuts are the distance between the bottom of the material, which is Z0, and the bottom of the tip of the tool. So this would be Z level 0, this Z 1.181, and this about 1.5 inches. So I'd feel comfortable with the tip of the tool rapiding across the table at 3 inches, and then I could wrap it down to 1.5 inches, which is still above my material top, 1.181, and I'm going to set my final depth to 1.181 as well. Even though I am going to need to make 2 passes to get my overall 1/4 inch depth, I'll leave this set to 1 and just apply a separate toolpath. There's nothing to set under machining data, and we do not want a lead in and out, and you can tweak the tool data if you wish. When I click OK, I'm only going to select one of the lines that I want to cut, and Finish to apply the toolpath. Now we want to lower this end of the toolpath to get our slope. I'm going to lower this end 1/8 of an inch for the first pass, and then I'll bring it to the final depth 1/4 inch in the second pass. I'm making 2 passes because the manufacturer's recommendations say the maximum removal amount is 0.197, and I want to cut to a total depth of 0.25. So I'm just dividing my finished depth in half to get 2 equal passes. So I'll edit in a -1/8 inch into the start point of my toolpath by going to Edit Machining on the Machine tab and then down to Edit Z Point by Point. When selected, we'll be prompted to select the toolpath. And when I do, I'll get 2 circles to choose from to change the Z value. Currently, they're both at 1.181, the top of the material. I'll click in this circle at the start of my toolpath, and I'll lower it by a -0.125. Then I can simply click here and type in -0.125, then enter or click OK. Then right-click to finish editing the toolpath. And if you go to an isometric or 3D view, you can rotate so that you can see a side view of the slope in the toolpath. Now I'm going to go back to a top view and apply the second toolpath with the first tool. So all the settings will be the same in Cut Shape, and I can go right to OK and select the same line again, and then Finish to apply the toolpath. Then I'll go to Edit Machining to change the depth at the start point to -1/4 inch. I'll click in the circle at the start of the toolpath and then subtract 0.25 from 1.181. You can view this in a 3D view again and see the toolpaths, the lowest one being 1/4 inch below the material top at the beginning of the toolpath. I'm going to use tools position 1, 2, 3, and 4 in this tutorial. So next I'm going to add in position 2. And I can see that the removal amount for position 2 is 0.008. So each end of the second tool will have to be that much lower. So we'll edit these values in after we apply the toolpath with the second tool, which we can select from the Select Tool window. And then we'll go down to the second tool, double-click on it, and click on the screen to make it active. Now we can go to Cut Shape. All the settings we're going to use are going to be the same. So we'll apply the cut, and then we can go to Edit Machining, Edit Z, Point by Point. I'll click in the circle on the higher end of the toolpath and change it so that it is negative 0.008 below the material top. Then I'll click in the circle at the start of the toolpath and change it so that it is negative 0.258 below the material top. And then I'll right-click to finish. Next, I'll select Tool Position 3, double-click, click to set it in the drawing, go to Cut Shape, verify my settings, OK, and apply the cut to the geometry. In this tool number 3, I'm going to set 0.006 lower than tool number 2. So that would be negative 0.264 for this end and negative 0.014 for this end. So I'll subtract those values from the material top using Edit Z Point by Point. And we'll repeat this process for tool position 4. Select the tool, cut the shape, calculate the depths for each end, and apply them using Edit Z Point by Point. Now with all our tools applied, we'll be able to view them in our Operations panel. We'll get a better visual to see that our tools and settings are correct by going to a front view so we can see a side view of the toolpaths and their depths. And now that I'm reassured that all these toolpaths look correct, I'm going to copy them to the other lines. By choosing Copy and then using a large enough window to ensure that I get all of the toolpaths. And then when I finish, I'll choose to only copy the toolpaths. And then always choose Linear Copying with Tool Sorting. This will give you the least amount of tool changes. And when asked for the base point, select from the endpoint of the line that you're copying from, and then select the endpoint of each line that you want to copy the toolpaths to. And then when we're finished, I'd like to go to an isometric view so I can watch my program run in simulation. If you don't already have simulation open in your project manager, you can open it on your View tab. And then you can shade solid and then play. Zoom in and adjust the speed as you wish to verify that each tool is running properly. And when you're satisfied, you can close simulation, go back to a top view, and send the G-code to your machine as you normally would. Thank you for choosing Park Industries.